So our first type of factoring that we're going to be talking about is using the greatest common factor to factor some polynomials. So here in this first problem, I have 16ab squared plus 20b. Now this would be the factored version of this, and we're going to talk about how I got from this point to this point. So if I'm looking at my original expression here, the 16ab squared plus 20b, I'm looking for what these two terms have in common. Okay, we have a 16 and we have a 20 as the constants that are next to these variables. So what I want to do is think about what is a factor or a number or two numbers that multiply together to make 16 and 20 that they have in common. Well, I know that I can divide 16 by 4, and I can also divide 20 by 4. I can divide 16 by 8, but I can't divide 20 by 8. So it seems like 4 might be my greatest common factor. So what I'm going to do is I'm going to take a 4 out of both of these expressions by dividing 16 by 4 and 20 by 4. That's how I got 4 and 5. 16 divided by 4 is 4, 20 divided by 4 is 5. Now let's look at the variables and what they have in common. Both of these sets have a b as a part of the term. So what I want to do is take one of those b's away, because if this would have been b squared, I could have taken both of the b's, or taken b squared out and taken both of the b's away from both the terms. But I just have a single b, so I'm going to take that single b out, which leaves me with only a b here instead of b squared, and it relieves this section of the b as well. So let's walk through number 2 together and talk about how we might be able to solve number 2 using greatest common factor as our factoring method. Now if I'm looking at number 2 here, the lowest number that I have is a 1. I can't reduce that 1 at all. Like, there's not a greatest common factor. The greatest common factor of 1 is 1, and if I divided every single one of these constants by 1, okay, then that means, of course, then I wouldn't be able to reduce those numbers at all. They're just going to stay. But what they do have in common is they do have these x. Every single one of them has an x variable. What I'm going to do is go to the lowest possible x variable, which is here just the plain old x, and that's what I'll be taking out of my expression. If I take an x out of every single one of these terms, that leaves me with x squared from this term. That leaves me with negative 8x from this term, and then just positive 12 here. I cannot reduce this or factor this out anymore at this point using my greatest common factor. And finally, let's look at number 3. Go ahead and pause this, do number 3 on your own, and then unpause it to see if I got the same exact answer that you did. Alright, so if I'm looking at all 3 of these numbers, I'm going to go to the smallest number and find the factors of that number. I know that 3 times 3 gives me 9, and that 9 times 1 gives me 9. Now, 3 is a factor of both of these numbers, but 9 is also a factor, and it's greatest common factor, so I'm looking for the greater number. 9 goes into 27 3 times, 9 goes into 72 8 times, and of course 9 goes into 9 1 time. So I'm going to pull that 9 out of every single one of the terms in that polynomial. So that leaves me with 3. That leaves me here with negative 8, and here with positive 1. Now I'm going to go to my lowest possible j value, which is just plain old j. Here I have j to the 3rd and j to the 4th. So I'm going to take a j out of the expression, which makes this j to the 3rd power, j to the 2nd power, and of course that will just remain as 1, because that j will be removed, and that would be my answer here for factoring this. So the whole concept with greatest common factor factoring is we're trying to reduce as much as we can out of this polynomial by taking out the greatest common factor in terms of the number and the variable in this polynomial.